Hey, does anyone know what happened to all the toilet paper? I think we ran out.
Oh yeah, I turned it all into vodka. Good luck.
That's right. Today we're doing a reverse Nile Red and turning vodka back into toilet paper. For those that don't know what I'm talking about, before the plague of 2020 and the days of hoarding toilet paper, my friend Nile Red made a video turning a batch of that most sacred of tissue into drinkable moonshine. Insane as this may seem at the outset, it quickly makes sense when you consider the chemistry involved. Cellulose, the main thing paper is made of, is really just long chains of glucose molecules stuck together. If you can break the chains apart and free the glucose, it's very easy to ferment that into alcohol. Glucose, after all, is just sugar. From there, a quick trip through a distillation setup and you've gone from TP to hungover. So how is it possible to go the other direction? One of the things that the cellulose to vodka route has going for it is that there is a readily available organism that will eat the provided glucose and turn it into ethanol, namely yeast. Which means that most of the work is actually breaking up the cellulose into a form the yeast can eat. Well, if we're allowed to use microbes, we actually have a ton of tools at our disposal. To tackle the reverse direction, we're going to need to break it up into two steps. First, we need to convert the ethanol back into a form which can be readily consumed by our microbe of interest. And then, that microbe will use that food and convert it back into cellulose. And while this is obviously a silly use of vodka, we'll see how the same microbes that let us do this might be the future of environmentally friendly paper products and even a few super materials. But before we talk super materials, let's at least manage some passable bog roll. To get started, while some people may be able to survive seemingly on nothing but pure booze, vodka for most creatures is not a highly nutritious food source. But while you might think we need some strange exotic organism to convert it back into food, we can actually just use the same organism that created it in the first place. Again, yeast. Strange as it may seem, yeast are actually quite capable of eating alcohol. If you grow yeast on sugar in an oxygen-free environment, they make alcohol. We call this fermentation. But give them oxygen and all that built-up alcohol becomes food too. This is called respiration and uses a different pathway. Rather than deep diving into the biochemistry and frankly giving anyone who's taken a biology class PTSD flashbacks as we go over the citric acid cycle, the important part is this. When oxygen levels are low, many organisms use a backup system so they can continue to function. In humans and other animals, this means making lactic acid as an end product instead of water, which is what they normally make with oxygen. Which is also why your muscles feel like they're burning when you work out. They're starved of oxygen and are literally acidifying themselves trying to survive. In yeast, their end product is ethanol, but for them, the last step is reversible. If oxygen suddenly becomes available again, they have a special pathway to convert the built-up ethanol back into a usable carbon source so it's not wasted. So while vodka might not be a good food source, the yeast themselves are. Yeast extract is an incredibly common reagent in both microbiology labs and the pantries of most vegans, because it's super nutritionally dense. Sort of like how we can't eat grass, but we can eat cow. As such, we have used it countless times on the channel because it's the perfect food for a huge number of other microbes. And sure enough, we found a bacteria capable of surviving on nothing but pure yeast extract that also produces cellulose. Allow me to introduce, and bear with my pronunciation here, Commegatebacter hansenii. Commegatebacter? I don't know. I give up. Beyond making me want to say Gesundheit, and a nice reminder that biologists are terrible at naming things, it's an absolutely amazing species. It is one of many which are capable of producing cellulose, and while they of course would prefer to grow on solutions rich in glucose or other sugars, much like the Australians, they can survive on yeast extract. And for those that didn't realize that's what Vegemite is, congratulations, now you know. Anyway, K. hansenii was originally isolated from kombucha, and anyone that's grown their own probably isn't that surprised. Kombucha famously grows a thick pellicle on the top of the culture that for a long time has been known to be about 50% cellulose, with the rest being proteins and other molecules. Those pellicles are actually amazing. Regardless of what you think about the drink, growing kombucha for the pellicle is a good time. If you dry it out and oil it, it forms a pseudo-leather that is remarkably strong, and it isn't a petroleum product like the other quote-unquote vegan leathers. However, kombucha is a mix of hundreds of different organisms. These pellicles are often called a SCOBY, or symbiotic colony of bacteria and yeast. By growing just K. hansenii, we can grow far more pure cellulose that is usable for all of the usual things that cellulose is good for. And it's one of the least picky organisms in the bunch, though it does require a lot of oxygen to grow well. As you can see, it also very readily forms pellicles of cellulose at the surface of a culture bottle. So our plan is to first use our bioreactor system to convert as much vodka into yeast biomass as possible, then boil the result, feed it to this bacteria, and produce paper from the result. And while using this bacteria like this is definitely silly, if we were to feed it things other than vodka, it goes from being comical to actually a big environmental boon. You see, a lot of human industry and the products we've come to know and love produce waste streams that are still rich in nutrients, they're just not useful to humans anymore. For example, in factories that make pasta, their runoff is often laden with starches. And the beer industry produces so much yeast as a byproduct, they had to invent Vegemite just to try and get rid of it. And while that is an option, there's a reason that it is, let's call it, a highly regional cuisine. If instead of just throwing these waste sources out, they were instead fed to a bacteria like K. hansenii, you could convert all of that leftover nutrition into high-quality cellulose for use in industry. Bacterial cellulose has found use in a variety of industries, from ultra-high-strength paper, acoustic filter panels, filtration membranes, and a growing number of medical uses, including repairing brains and as a scaffold to grow replacement tissue on. There was also a paper recently that showed that tweaking the growth conditions can make sheets that once dried are insanely strong, and we are definitely going to give that a try in the future now that we've got a sample of this cool bug. So, while it will never replace more traditional sources of cellulose like forestry, it can be used to reduce the environmental impact of other industries, while generating a value-added product. I also wonder if there would be a way to extract the nutrients out of sewage to produce paper this way. It would be kind of amazing if every time we flush and waste a little bit of TP, it got regenerated for reuse later. We could call the project the Shit of Theseus. As it stands, a huge amount of our old-growth forests have been cut down, ground up, and shipped out as butt paper, and planted in their place are giant expanses of pine trees in perfect rows waiting to be cut down again. These expanses are called green deserts, and while they may look nice in a picture, up close you find them actually pretty devoid of life. Even when a logging company stops cutting them down, it can be incredibly hard for the ecosystem to recover. What we really need in these areas is what's called rewilding. This means taking a human-disturbed ecosystem and putting in just a little bit of effort to help the normal ecological processes get started again. I absolutely love rewilding projects and supporting people trying to make the Earth healthier again. So I am very excited to have partnered with Planet Wild, a community-based nature restoration organization that also happens to have an amazing channel here on YouTube. If you've not seen their missions or videos before, they use community funding to support rewilding projects all over the world. Think of it like crowdfunding for nature. They've given hundreds of thousands of euros to a huge variety of projects already, including one rewilding a green desert in Scotland. There, they show how, counterintuitive as it may seem, using a winch to yoink down trees and create dead wood is an amazing boost to the ecosystem, as it provides new homes and opportunities to a multitude of creatures. As all of their missions, it's documented on their YouTube channel so you can see what your contributions have achieved. I'm a member myself, and if you'd like to join me in making a difference for nature, consider becoming a member too. You can give whatever amount, big or small, whatever feels right. After all, every dollar that goes to protect nature is a dollar well spent. Finally, as a special gift, the first 100 people to sign up using my code Emporium1 will get their first month paid for by me. Just scan this QR code or click the link in the description. And the best part? You'll immediately have an impact in nature and see the result in less than 30 days here on YouTube. And there's no catch, you can cancel anytime. If you want to see Planet Wild in action, check out their latest mission where they rewild the Green Desert in Scotland, which I've linked in the cards and description. Now, while they work on fixing the planet, let's work on rectifying our rectal retinue and return to reproducing recycled toilet paper. Sorry, I ran out of R words. To get our paper-making process underway, we first need to figure out what concentration of vodka to use. As you may know, yeast are only capable of producing up to a certain alcohol percentage, because beyond that point, the alcohol itself becomes lethal. And too close to that limit, even if they are growing, it's going to take forever. Also, while it would be awesome to grow yeast just straight in a bottle of vodka, that would violate both the laws of physics and biology, because every organism needs more than just carbon and oxygen to survive. So for each batch, big or small, we need to add a specific amount of something called yeast nitrogen base. This stuff is mainly minerals and salts, things like iron sulfate, calcium phosphate, ammonium nitrate, zinc, and so on. Without this, the yeast can't function and eat the ethanol, but it doesn't meaningfully contribute any carbon for them to convert into biomass. Essentially 100% of that will come from the ethanol. To figure out the best vodka concentration, we ran some tests with our new baby bioreactors. You'll see more of these in an upcoming video, but they let us monitor the growth and do a bunch of small-scale tests to dial in the exact concentration that'll work best. Finally, we also need the yeast itself. In this case, I went with a wine yeast to maximize the ethanol concentration that it can survive. When all was said and done, we found that about 6% ethanol provided the best balance of speed and biomass production. Less than that, and you don't get enough yeast. More than that, and it starts to take forever to grow. Knowing that, we can finally get to the big production. To actually make our paper, we're going to need quite a lot of yeast, which means that it's time to fire up our big bioreactors. We showed these off in our recent video making penicillin, and this whole system was built in-house from scratch. The bioreactors are based on 1.5 liter beakers, and the cabinet can currently hold 12 reactors at once. So it's time to do a little amateur mixology and make our yeast growing cocktail. This includes a healthy 150 milliliters of vodka, 6.5 grams of yeast nitrogen base, and the rest is some refreshing water to thin the mix so our yeast don't get too drunk. This gets autoclaved to make it sterile, as we've shown many times before, and it gets inoculated with a little bit of our yeast solution once it's had time to cool back down to room temperature. All that's left is to install it in the reactor cabinet and let it grow. We gave it a few days to make sure that all of the vodka was consumed, and off-camera ran several more reactors so we could work our way through the whole bottle. The nice thing is, we don't really have to do anything fancy to prepare this for the next step. Pretty much all that's required is to just take the lid off and boil it for a while. This will pop open all of the yeast, releasing their delicious juices into the water and creating in situ yeast extract. Now, as you saw from the culture bottle of K. Hansenii, the layer mainly grows at the liquid-air interface. So to maximize our yield of cellulose, we got these short, wide bins. The plan is we're only going to add 1 centimeter or 2 of liquid in here and leave the rest as airspace. The boxes were thoroughly sterilized with alcohol, and once dry, we poured in our now cooled yeast extract. When we did this, we made sure to decant off only the top liquid and not pour all the dead yeast particles in, so our cellulose comes out cleaner. Each bin then got a dose of K. Hansenii, and these could again be brought upstairs to grow in the bioreactor cabinet. It's a space that won't get disturbed, so any layers that grow should be nice and thick. Now all we have to do is wait. Over the course of about a week, we saw the bins slowly go from being liquid to solid as the bacteria did their work, and I am thrilled with how nice this time-lapse came out. You can really see the whole process. Now the exciting part. We brought the bins back down to the biolab for harvest, and even just carrying them it was pretty obvious that this had worked. And cracking them open, we were greeted with a cellulose mat that looks equal parts disgusting and delicious. The smell, on the other hand, not great. If you thought kombucha smelled bad, this stuff, much worse. Though not all of our bins came out this clean. A few had a spot of mold that needed to be removed. Thankfully, we can just cut around those spots with scissors and then throw them out. But doing this made it painfully clear why you definitely shouldn't try and eat this. The texture is sort of like silver skin from a piece of meat if that skin was half an inch thick, and kinda partly layered.
Welcome to this week's horrifying monstrosities.
Yeah, if they think it's bad fucking watching it, imagine having to do this.
We squeezed out as much water from the slabs as we could before transferring them to a freeze-drying tray. We loaded up as many of the trays as we could, and then it was off to the freeze dryer. We wanted to completely dry the slabs out while still leaving them puffy and kind of fragile. This way, it'll be easier to break them up into tiny shreds for making paper. Sure enough, it came out of the machine as these big sheets, which were easy to crunch up with just my hands. This already looks a lot like shredded paper, but we need to reduce the flakes in size as this is still way too big for actual paper making. But a quick trip through a blender does most of the rest of the work. Though in hindsight, I really should have blended this finer. You'll see why in a moment. To deal with the fact that this is literally as suffused with bacteria as pretty much any piece of paper can really get, we dumped the powder into a beaker and then hit it with a bleach solution. This will kill off anything that's left in there and hopefully make it a little bit less yellow. After all
yellow chemistry is trash.
But with that done, let's get to paper making. We picked up this simple paper making kit and a bin to work in. We strained out all the paper pulp from the bleach, gave it a rinse, and then dumped it into our paper making bin with a bunch of extra water. We also added a tiny amount of PVA to act as a binder to sort of help everything stick together as it dries. Now, this is the part where we realized two things. First, the dried paper bitties swell immensely when you rehydrate them. And also number two, if you don't shred them enough, you end up with a noodly mess that clings to, well, pretty much everything. But at this point, we were basically committed, so we just went ahead to try and make some paper. This did not always go to plan, and sometimes, even if it did, the noodliness of it made the paper refuse to come back off the mesh later. But after fighting with it for a while, we ended up with a few piles of mush that the instructions assured me would turn into paper. Sure enough, after a day or two of drying, the mush had flattened completely out into what seemed like some really nice sheets, though removing them from the backing cloth was a challenge in and of itself. But there we go, we made real paper from nothing but vodka, and it's stronger than it looks. I was able to cut a piece to be basically square and then used my ADHD fidgeting skills, honed over many years, to delicately fold a paper crane. I always used to do this when I was in class, especially during exams. I could tell how difficult the exam had been by how many paper cranes I had time to make before we were allowed to leave, and a particularly boring class would have my desk looking rather decorative. However, there is one crucial test left to make sure this paper is butt grade. We're going to need to wipe. Since this is YouTube and not OnlyFans, we're going to simulate this function using this piping bag full of Nutella. A little swirl and two googly eyes later, and we have our turd stand-in. We're going to call them Tim. Tim the Turd. Now, choosing one of our less nice pieces to sacrifice to the cause, we gloved up, lined up the maneuver, and... success! Next, for a fold, and the final cleanup pass. And there we go, Tim has been collected, and there's only a minor skid mark. Sure, we're not expert paper makers, but we proved the point and have a few sheets left over we can do some fun stuff with. Stay tuned for a short to see what we have in mind on that front. Either way, we have successfully completed our reverse Nile Red challenge. I've been joking with Nigel for years that if I ever ran out of ideas for videos, I could make a whole career just out of reversing his videos. But even I would have a hard time turning hot sauce back into lab gloves. But maybe I should try. If you enjoyed this video, as always, be sure to subscribe so you don't miss our future monstrosities. And we of course need to say a special thank you to our amazing patrons that help make these videos possible. Don't forget to check out Planet Wild, links in the description, and we'll see you next time.